Hi everyone, we are Group 4 from FF2 and we will be talking about machine learning. As the tagline says, machine learning is the science of making machines intelligent, giving computers the ability to learn and make their own decisions. So, these are the contents that we will be sharing on. Let's head on to the first one. The main definition of machine learning is that it is a branch of artificial intelligence where computer systems learn patterns from data and improve their performance on tasks without being explicitly programmed. In simpler terms, it's about teaching machines to learn from experience the way humans do, but through data and algorithms.
First, from other sources, we have Professor Arthur Samuel, who was a professor at Carnegie Mellon University, computer scientist at IBM, pioneer in AI and computer gaming. He said that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed, similar to the general definition. Continuing on, we have Professor Tom M. Mitchell, who is also a professor at Carnegie Mellon University and an author of the classic textbook Machine Learning in 1997. He says that a computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. So this definition is based on the formula which he formulated during his research. Next, the Oxford Dictionary defines machine learning as the use and development of computer systems that are able to learn and adapt without following explicit instructions by using algorithm and statistical models to analyze and draw inference from patterns in data. Lastly, we have International Business Machines Corporation, or IBM. Machine learning, as defined by IBM, is a branch of AI that uses data and algorithm to mimic human learning, enabling systems to improve performance and accuracy automatically over time.
Now let's move on to the types of machine learning. So there are 4 main types. First is supervised learning. The model learns from examples that already have the right answers. By studying these labeled examples, it can make predictions or decisions when faced with new data. Second one is unsupervised learning. The model works with data that doesn't have labels. Its job is to find patterns or structures on its own, like grouping similar items together or simplifying complex data. Third one is semi-supervised learning, which is a mix of the first 2 types, where the model it gets a small set of labeled data and a large amount of unlabeled data. The labeled examples help guide it, so it can learn more effectively without needing every data point labeled. Lastly is reinforcement learning. This type is all about trial and error. A system called an agent, it interacts with an environment and tries different actions, gets feedback in the form of rewards or penalties. Over time, it figures out which actions leads to the best outcome. Next is the pros and cons of machine learning. Let's start with the pros. So first is automation of tasks, meaning machine learning can perform repetitive or complex tasks automatically, saving time and reducing human effort. And the second one is improves decision making. Machine learning can analyze a large amount of data to identify patterns and make accurate predictions, helping businesses and individuals make better decisions. As for the cons, we have data dependency, meaning machine learning models require large and high-quality data sets, and without data, predictions can be inaccurate. And the second one is bias and fairness issues. So if the training data is biased, the machine learning model can produce unfair or discriminatory outcomes.
First, we have to know what a case study really is. A case study based on machine learning is a detailed examination of a particular real-world application, dataset, or problem where machine learning techniques are applied, analyzed, and evaluated to understand their performance, challenges, and outcomes. So there are a few examples that we're going to show today. One of the examples are machine learning model for predicting long-term energy consumption in buildings. So in brief, this study explores using XGBoost, SVR, and LSTM models, which are machine learning models, to predict long-term building energy use, linking environmental factors with design for sustainable growth and improve energy optimization as a response to carbon emissions and energy consumption that has gone up as a result of the building industry's explosive rise. In depth, this paper discusses the impact, reliability, and significance of machine learning. Next, we have machine learning in agriculture industry. Agriculture serves as a vital pillar for national economies and global food security, yet it continues to encounter persistent challenges arising from limited access to actionable data, reliance on outdated farming practices, and sufficient integration of modern technologies. So, advantages of machine learning in agriculture are improved efficiency and productivity, enhanced decision making, farmer support and navigation, and lastly, targeted interventions. Lastly, we have predicting thyroid disorders using machine learning techniques. This study explores the application of various machine learning models, including assembly techniques like random forest and decision tree, to predict thyroid disorders accurately by analyzing comprehensive clinical data, thereby supporting early diagnosis and effective treatment to address the rising prevalence of thyroid diseases.
Next is the applications of machine learning. First, we have prediction and forecasting. So, machine learning forecasts outcomes by learning from past data, such as material behavior, equipment performance, or environmental changes. Second is monitoring and maintenance. Machine learning enables continuous monitoring of systems and structures, detecting early signs of damage, anomalies, or potential failures to support predictive maintenance. Third is optimization and design. Machine learning helps optimize design and operations, improving efficiency, reducing costs, and promoting sustainable practices. Fourth one is classification and pattern recognition. So machine learning organizes data into meaningful categories or identifies hidden patterns, aiding informed decisions and risk assessment. Fifth one, automation and robotics. Machine learning powers autonomous machines and robotic systems, enhancing safety, productivity, and automation across industries. And the last one is data analysis and insights. Machine learning handles large complex data sets to extract insights that guide strategic planning, resource management, and smarter decision making.
So all in all, machine learning is a transformative technology that powers many aspects of modern life, from healthcare to finance to entertainment and transportation. Despite challenges such as data dependency and bias, its ability to improve accuracy, efficiency, and decision making makes it essential in today's world. Rather than replacing human, machine learning complements our abilities, driving innovation and shaping the future of intelligent systems. Alright, and that's all from us. Thank you.